Let us look at an example to understand how a firm which needs to borrow at a future date could hedge using interest rate futures against a potential rise in interest rates. Let us say that today, 8th April 2016, a firm comes to know that to finance one of its short-term projects, it will have to raise a loan of 15 million US dollars starting 10th June 2016. That means 2 months hence for a period of 3 months. A bank has agreed to provide this loan to the firm at the 3-month LIBOR rate prevailing on the start date of the loan, that is 10th of June 2016. The borrowing firm is obviously concerned about the possible increase in interest rates between today, the 8th of April 2016, and the start date of the loan, 10th June 2016, and would therefore like to hedge itself against any adverse movement in interest rates in the intervening period. Let's say on 8th of April 2016, that is today, 90-day June interest rate futures, that means interest rate futures settling on 30th June 2016, is trading at USD 99.40, implying an interest rate of 100 minus 99.40, which is 0.6% for 3 months or 2.4% per annum. While the firm cannot lock in the borrowing rate prevailing today, 8th of April, for a loan commencing 2 months later, that is 10th of June 2016, it certainly can lock in the 3 months USD futures price of 99.40 prevailing on 8th April 2016, and thereby, as we will see, assure itself of an effective borrowing cost of 2.4% per annum or something close to that. The company will achieve this by actually going short, that is sell, today, 8th of April, interest rate futures contracts worth 15 million US dollars at 99.40, settling 30th June 2016. The underlying asset governing the 90-day interest rate futures contract, let us say, is US Treasury bills. This action of going short or selling in the interest rate futures market is equivalent to selling bonds or raising a loan today, 8th of April 2016, at 2.4% per annum, maturing on 30th June 2016. Since one futures contract is equal to 1 million US dollars, the firm will be required to sell 15 contracts equivalent to US dollars 15 million, which is the loan amount, at an effective interest cost of 15 million US dollars into 100 minus 99.40 divided by 100, which is equal to 90,000 US dollars. We will now see how this 90,000 US dollars will be the interest cost to the firm, irrespective of which way the 3-month interest rates move between today, the 8th of April, and the start date of the loan, 10th of June 2016. We look at 2 scenarios to understand this better. One where the interest rate goes up and the other where the interest rate goes down between 8th of April 2016 and 10th of June 2016. Scenario 1. Say on 10th of June, we have now moved to 10th of June. 10th of June 2016, interest rate futures with settlement date 30th June 2016 is trading at 99.25 US dollars. So the implied interest rate for a 3-month loan commencing 10th June 2016 will be 100 minus 99.25 into 12 divided by 3, which is equal to 3% per annum. The firm will undertake 2 transactions on 10th of June 2016. One, borrow USD 15 million from the bank for a period of 3 months at the prevailing rate of 3% per annum start date 10th of June 2016, maturing 10th September 2016, and 2. Buy 15 interest rate futures contracts of USD 1 million each at 99.25. This is done to square the 15 interest rate futures contracts of 1 million each that it had sold on the 8th of April 2016 at 99.40. Cash flows resulting from the above two transactions will be 1. Interest expense on the loan commencing 10th June 2016 will be 15 million into 3% into 3 divided by 12 equal to 112,500 US dollars. For the futures contracts that were sold at US dollars 99.40 on 8th April 2016 and squared, that is bought at 99.25 on the 10th of June 2016. Remember, both transactions will settle on 30th June. The effective gain will be 15 million into 99.40 minus 99.25 divided by 100, which is equal to 22,500 US dollars. Therefore, the net borrowing cost to the firm will be the interest on the loan 112,500 less the gain in the futures transactions of 22,500, which is equal to 90,000 US dollars. Scenario 2. Let us say on 10th June 2016, interest rate futures with settlement date 30th June are trading at 99.50 US dollars. Hence, implied interest rate for a 3-month loan commencing 10th June 2016 will be 100 minus 99.50 into 12 divided by 3, which is equal to 2%. The firm will undertake the same two transactions as in scenario 1 on 10th June, which is borrow USD 15 million from the bank for a period of 3 months at the prevailing rate of 2%, and 2. Buy 15 interest rate futures contracts of $1 million each at 99.50 to square the 15 interest rate futures contracts of 1 million US dollars each that it had sold at 99.40 on 8 April 2016. Cash flows resulting from the above two transactions will be 1. Interest expense on the loan commencing on 10th June for 3 months, 15 million US dollars into 2% into 3 divided by 12, which will be 75,000 US dollars. And the loss incurred in the futures contracts sold at USD 99.40 on 8th April 2016 and bought at 99.50 on 10th June 2016, both settling on 30th June 2016, will be 15 million into 99.50 minus 99.40 divided by 100, which will be a loss of US dollars 15,000. So the net borrowing cost is 75,000, which is the interest on the loan of 15 million at 2%, plus the loss on the futures contract of 15,000. The total US dollars 90,000. As you can see from the above two scenarios, in the first case, an increase in interest rate between 8th April and 10th June from 2.4% per annum to 3% per annum results in an increase in the borrowing cost, which is offset by a gain when squaring the futures transactions on 10th June 2016. In the second scenario, a reduction in the borrowing cost due to fall in interest rates between 8th April and 10th June from 2.4% to 2% is offset by a loss on the futures transaction. In both cases, the firm's effective interest cost for the loan is constant at US dollars 90,000, an effective interest rate therefore of 2.4% per annum that, remember, it could lock in through an interest rate futures transaction on 8 April 2016, thus enabling the firm to hedge against interest rate fluctuations in the intervening period. Hope that example has helped you understand how a firm can hedge against interest rate fluctuations in the future using interest rate futures. Those of you who wish to pursue this topic in greater detail, please refer to the textbook Options, Futures and Other Derivatives by John C. Hull. In the next session, we will look at how firms use interest rate swaps to hedge against interest rate risks.